When we last met, we were talking about the importance of the mole. Okay? We were talking about why we use the mole. Atoms, FUs, which stands for formula units, and molecules are so small that it's only when we get to have huge numbers of things are we dealing with enough to be able to count in grams, to be able to measure in grams. Okay? We have numbers that we're used to. A couple means 2. You have a couple of atoms in the palm of your hand. Can you see them? No. Can you measure them? No. Okay, well, couple, throw that one away. How about dozen? No. Dozen means 12. If we have a dozen atoms in the palm of our hands, can we see them? No. Can we okay, we'll throw dozen away. How about gross? Gross is a dozen dozens, 144. If we have 144 atoms in the palm of your hand, can you see it? No. Can you measure it? No. So throw a dozen away, a gross away. How about a ream? 500. We have 500 atoms in the palm of my hand. Can we see those atoms? No. Can we measure them? No. Throw them away. All right. It's only when you get to a number that is so big that we cannot comprehend do we have enough atoms that we can feel, we can touch, we can play with, and more importantly, we can measure with a balanced scale. So, 1 mole of any atom is equal to its atomic mass in grams. So these numbers, the mass numbers, the numbers that are below the symbols, now all those become important. So what does that mean? Look at this. This is sodium chloride. That is a pile of sodium chloride. There are 6.02 times 10 to the 23rd FUs. And that's the word that we use to refer to the smallest particle of an ionic compound. More importantly, there are 58.5 grams in there. How do I know? Did I measure them? I don't have to. Because if I know there's 1 mole in there, all I have to do is add up the mass of sodium, which is 23, and the mass of chlorine, which is 35.5. 23 plus 35.5 is 58.5. This is copper. This is 1 mole of copper down here. Can anyone tell me its mass? Find the price list. Where is the price list, Mr. Moreno? Your periodic table. What is the price list of copper? So there should be 63.5 grams of copper there. What about H2O? How many grams of H2O are there if you have 1 mole of it? No. 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 Hydrogen. 18. Hydrogen is worth $1, and you have 2 of them. Oxygen is worth 16. 16 plus 2, 18.0 grams. It's that easy. So, the mass of 1 mole of anything is equal to its atomic mass in grams. So what do? Look up sulfur on the periodic table. What is its mass? $32.10 in grams. We've already said copper is $63.50. What about a FU that has 2 coppers and a sulfur? Use your calculators. 63.5, and you have 2 of them, and then 32.1. What is it? 159.1. How about an oxygen molecule, which is made up of 2 oxygens? One decimal place with all of these. 32 and 32 is 64. Yes. Copper oxide, Me. These are called molar masses. Why are they called molar masses?
Those are masses of moles.
The mass of moles of things. That's right. The mass of, we cannot determine the mass of individual particles. So we have to be able to determine the mass of moles of things.
All right, follow me here. 1 mole of carbon-12 contains 6.022 times 10 to the 23rd atoms and weighs 12 grams, right? So 1 mole of oxygen also contains 6.022 times 10 to the 23rd atoms, but because oxygen atoms are more massive, it weighs 16 grams. And you'll recall that oxygen's relative atomic mass is 16 AMUs. The number of atoms per mole remains the same, but the mass of a mole depends on the average mass of the element. This simply means that 1 mole of any element equals its relative atomic mass in grams. So now you got it. 1 mole of hydrogen weighs 1.008 grams, a mole of iron is 55.85 grams, and a mole of natural carbon is 12.01 grams. This is known as an element's molar mass. And now that we know the molar mass of elements, we can calculate the molar mass of any compound. All we have to do is add up the molar masses of its component elements. So for instance, the formula for this sugar, or sucrose, is C12H22O11. 1 mole of sucrose, by definition, contains 6.022 times 10 to the 23rd molecules, and since each molecule contains 12 carbon atoms and 22 hydrogen atoms and 11 oxygen atoms, then 1 mole of sucrose contains 12 moles of carbon, 22 moles of hydrogen, and 11 moles of oxygen. Multiply the number of moles of each element by its molar mass and add them up. That's the molar mass of the whole compound. See the...
All right. It's that easy. Okay, let's try these. Before you get started, the only one that might be tricky is this one right here. All you need to do is remember to use the distributive property. So what does that 3 mean? That means you have 3 oxygens, 3 hydrogens. Okay? So imagine you're at the store, it's Black Friday, and you have a price list. You go and get these things. You should know how much they cost before you get to the counter. Go. Always. And units down. Everyone's working quietly. Isn't that wonderful? Let's continue. Except for Asher, who breaks the silence by tossing his calculator across the room. And now forevermore it'll be in YouTube.
I hate calculators.
Thank you.
Oh, yeah.
Any questions? It's Molar Mass. Fairly easy start to a tough week.
Should we quiz on this?
Eventually, yes.
Just this.
Eventually, yes.
How did you get? Wait, go back. How did you get 324.1?
Oh, I don't know. 96 plus 28 plus 400.2 is 524. 524.2. Good? All right. It would be really easy week if we could stop right here, but the fact is that we cannot. The state has decided that it's not enough. We have to be able to convert from moles to grams and grams to formula units or molecules or atoms, which makes things a bit more complicated. So let me show you the way in which you can do this without really needing to think about it too much. Okay? First thing you need to understand is that mole amounts are tiny little numbers. We're talking 1.3, 0.59, 2.6, 0.93. Yes, sir.
What is that word?
Tiny.
Above that.
Mole.
Above that. Stoichiometry.
Stoichiometry. The measuring of stuff.
What language is that
Greek.
in?
All right.
When in the first one, child.
Grams are going to be normal numbers. Something to the tens or the hundreds. Numbers that we can relate to. Okay? And then FU, atoms, molecules. Those are huge number. Numbers that are times 10 to the 23rd or times 10 to the 24th. Somewhere in that range right there. Monstrous. Now, right now it seems like this is unattainable unless you realize that all you need in your toolbox is 4 tools. Number 1, you need to be able to hit the multiplication button. Number 2, you need to be able to hit the division button. Okay? That's 2 out of the 4 tools. Number 3, you need to be able to do what we just did, the molar mass. And number 4, you need Avogadro's number. Avogadro's number, 6.02 times 10 to the 23rd. Take out your calculators. Let's talk about exponents and how to punch them into your calculator. Okay? Let us punch this into our calculator. Follow me. 6.02. Put 6.02 on your calculators. Okay? Now, some of you are going to want to use you're going to actually want to say times 10. That becomes a little tedious. So let me show you a shortcut. Hit second comma. Second comma. That should give you a little e. Raise your hand if you got the little e. Little e? Okay, sorry. Little e?
Yep.
Little e?
Yep.
Tanaya? Little e? Little e? Okay, that means, that little e means times 10. That little e means times 10. So now it's waiting for the power to take it to. So hit 23. Hit 23. So from now on, this is the way I want you to do it. If you want to say times 10, you got to have that little e. And then in normal script, whatever power it's at.
Can you write that? 6.23.
Second comma 23 should give you 6.02 little e 23. Now this number we're going to use so often that it would be good to program our calculators to be able to instantaneously recognize it. So I want you to look on the lower left hand corner of your calculator buttons. I want you to look for the button called STO. S-T-O. See it? Okay, once you hit it, you should see an arrow appear next to the 3. Are we good so far? Now, we are going to program it to be recognized by, to be symbolized by a letter. And Avogadro's number is symbolized by the letter N. So, hit the alpha button and then log. And that should give you the letter N.
Where's the E button?
Right there.
Comma.
Okay? Does it say 6.02 little e 23 arrow big N? Hit enter. Now, every time you say alpha N, the calculator will think 6.02 times 10 to the 23rd. Let's try it. 5 moles to grams.
Did you press enter?
Yes.
I got error.
Then you did it wrong. Moles to grams. Okay? What kind of number is moles? Tiny. What kind of number is grams?
Normal.
Normal. All right. So let's think about what we're going to have to do. First of all, in order to go from tiny to normal, do we multiply or divide? We're going to have to make it bigger, so we're going to have to multiply. All right, that's one of these tools. Should we multiply by molar mass, which is the sum of all the mass for O2, or should we multiply by Avogadro's number? Okay, think about that. If you multiply by Avogadro's number, how big a number are you going to get?
Huge.
Huge. Do we want huge?
No.
No, we just want normal. So what are we going to have to multiply? Your choices are molar mass or Avogadro's number.
Molar mass.
Molar mass. All right, so what is the molar mass of 2 oxygens? So 5 times 32.0 is 160.0 grams. Make sure you have units or else it'll be counted wrong. Good start? Okay. Big number! And it's going down to mole, which is
Mole.
tiny. Okay, so we're going to have to make a big number become tiny. Do we multiply or divide? Divide. All right, let's set it up. 2.85 second, comma, 23 divided by. Okay, how do we make a huge number become tiny? Do we divide by molar mass? Or do we divide by Avogadro's number? Avogadro's number. So type in alpha n. Alpha n. Hit enter. Is the number tiny?
Yes.
No.
Then we did it right. What is it?
0.47. I didn't work.
473.
Well, too bad for you.
I did exactly what you told me.
No, you didn't.
You do not have it programmed properly. You'll have to wait till I get a chance to get over there and help.
Hold on. Hey, hold on.
Yes.
2.85 second comma.
Second comma gives you the little e,
Get your E. Okay. Okay. So, oh, so, okay. Okay. All right.
which is times 10.
Okay.
All right, here we go. Letter C. I'm giving you an example of each type so that you can be able to do your
I
homework.
don't got no tie.
Oh my god. Oh my gosh, yes.
What?
That is the young man.
Okay. Grams is what?
You don't have it stored.
Tiny, normal, or huge?
Normal.
Normal. Mole is tiny, normal, or huge? Okay, so we're going down. So we're going to have to take this number and divide by Avogadro's number, or formula mass. Formula mass. Okay. 23 times 2 plus 12 plus 3 times 16. The smallest particle, Emily, of sodium carbonate is called an FU. We're not converting to FU, we're converting to moles. All right, so what is it? 106.0. So 56 divided by 106.0, do we get a tiny number? What do we get? You know, this is assumed.
0.35.
How did you get that? I got 0.52.
Oh, wrong number.
Okay, Jeffrey, if I were you, I would just remove the batteries from your calculator.
0.52.
Okay, 0.53. Round it up. All right. Here we go. Mole. Big or tiny? Tiny. Molecules. Big, normal, or tiny? Huge. So we're going from tiny to huge. Do we multiply or divide? By molar mass or Avogadro's number. All right, 3.50 times n. Do you get a huge number?
2.107.
Yes.
2.107 E from 4.
I didn't get no number. I got an equation.
Exactly. That's how you're supposed to.
I got
2.107 times.
Oh, yeah.
All right, letter E and letter F. You have a problem. It's a calculator issue, sir. So let me just go on and then I'll help you with the calculator.
What if we just put
Grams to FU. Moles to FU, we've done. Yes. FU to moles, we've done. Yes. Moles to grams, we've done. Yes. Grams to mole, we've done. Yes. Grams to FU, we cannot do. So what do we do? If you cannot go directly from grams to FU, what are we going to have to do?
Oh, I hate.
Go through moles.
Okay, can we go grams to moles first?
Yes.
And then moles to FU second. All right, grams to moles.
All right.
You're going from normal down to tiny, divide or multiply.
Divide.
And the formula mass for NaCl we've already determined to be 58.5. So 90 divided by 58.5. 1 point. And now, what do we do to go to FU? Multiply by N.
Okay. 9.626153462.
Are you trying to impress me by how many digits your calculator can take that to? Then stop. 9.26 is good enough for me. All right. So we have to go through the mole. We have to go through the mole. What about this one? FU to grams. Can you go FU to grams or grams to FU? No. So we have to go through the 5.68 little e 24. To get it down to mole, what are we going to have to divide by? Molar mass or Avogadro's number? Avogadro's number. Molar mass will not touch this. Molar mass will not make it tiny. Avogadro's number will. 5.68 little e 24 divided by n gives you?
9.4.
Is that a tiny number? Yep. Tiny enough for me. And now, if we want to go to grams, what do we do? Multiply or divide? Multiply by 58.5. What is it?
547.41.
All right, I did one of every kind that you will find in your homework tonight. I'm going to stop this right now and go